Okay, this is Module 5, Lesson 9, and our learning objective today is I will be able to use the area model and division to show the equivalence of two fractions. Notice in this lesson, and I think in the next couple lessons, we're going to be using division here instead of multiplication to show the equivalence of two fractions. And the cool thing is it's basically just kind of going backwards or doing the reverse of what we've been doing, going from now the smaller fractional units to the bigger fractional units using division instead of multiplication, since we know division and multiplication are opposites. So let's go ahead and read the directions for the first page, and I'm on page 39 of the workbook. Let's see. So this is lesson 9. Each rectangle represents 1. Compose the shaded fractions into larger fractional units. Express the equivalent fractions in a number sentence using division. I'm going to skip the example problem. You can look back at this if you need to. I'm going to go right to B. Okay, so I'm looking at my area model, and I notice that, let's see, what are my smaller fractional units? I'm going to go from smaller to larger in this problem, in all the problems. Smaller to larger using division. Okay, so my smaller fractional units, let's see, it's 1, 2, 3, 4, 5, 6. My area model is divided into sixths. So each of these little boxes is 1/6. 1/6, so there's 6/6, and then the area that's shaded is 1, 2, 3/6. Okay, so I have 3/6, and then I have to show the equivalent fraction using division. So what I'm going to look for now is what area using the larger area of the area model does 3/6 account for? Well, I can see that it accounts for 1/2 here, and here's the other half. So 3/6 is the same as 1/2. So I have to divide by something over something to get 1/2. Okay, and just like with multiplication, we are going to divide by a fractional number that equals 1. So 3 divided by 3 equals 1, and then 6 divided by something equals 2. Well, 6 divided by 3 equals 2. So we're dividing by 3 over 3 here to get to 1/2. Just like if we were going the opposite way, we'd be going 1/2 times 3 over 3 gives me 3/6. So you can do it either way, going from smaller to larger or larger to smaller. Smaller to larger is division. Larger to smaller is multiplication. Okay, let's do another practice problem. Let's go ahead and do D. And again, I'm going to go from the smaller fractional unit to the larger fractional unit. So I'm going to see what my smaller fractional unit is first. Let's see how many parts my area model is divided into. 1, 2, 3, 4, 5, 6, 7, 8 parts. Therefore, each of the little parts is 1/8. And I can go ahead and label my little parts. 1/8, 1/8, 1/8, 1/8. You don't have to label all of them like this, but if it's easier for you to keep track, go ahead and just label your little parts. Okay, so I can tell that the shaded fraction is the same as 1, 2, 3, 4/8. Okay, 4/8. And now I'm going to look at the whole area model, and I can see that the shaded part again equals 1/2 of the whole area model, and then here's the other half. So I know I need to divide by something over something to get 1/2. Well, 4 divided by 4 equals 1, and 8 divided by 4 equals 2. So I'm divided by 4 over 4 to get my equivalent fraction. Let's go to a problem on the next page. Number 2 says, compose the shaded fractions into larger fractional units. Express the equivalent fractions in a number sentence using division. So this is a very similar type of problem. Let's go ahead and do the first one. And I'm going to go from a smaller fractional unit to a larger fractional unit. So I'm going to count, I'm going to try to determine what is my smaller fractional unit in this area model. Well, I can just count to see how many smaller fractional units the area model is divided into. Let's see, 1, 2, 3, 4, 5, 6. Therefore, this is 6, and that's 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. And I can see that the shaded part is 1 2/6, 2/6. Now I'm going to look at the bigger area model, and I can see that this shaded part represents 1/3 of the entire area model, because this section represents 1/3 and this section represents 1/3. So again, you're going from the smaller fractional unit to the bigger fractional unit. So I need to divide 2/6 divided by something over something to get back to 1/3. Well, 2 divided by 2 equals 1, and 6 divided by 2 equals 3. So 2/6 divided by 2 over 2 equals 1/3, going from the smaller fractional unit to the larger fractional unit. Let's try number D here. Again, I'm going from the smaller fractional unit to the larger fractional unit, so I'm going to first figure out, well, what is my smaller fractional unit? Well, I'm going to have to count all these little smaller fractional units to determine that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my smaller fractional unit is 1/12, 1/12, and I could label all these. I'm just, for the sake of time, just going to label the 2 that are shaded. So now I know that the shaded part represents 1 2/12. So 2/12 here, right? And then I got to divide it by something over something to equal the larger fractional unit. Okay, so I'm looking at this area shaded here, right, in the whole area model, and it looks to me like that these two little shaded areas together represent, let's see, 1, 2, 3, 4, 5, 6, 1/6 of the total area model, right? So I'm looking at these two shaded areas together, and I'm looking at this column versus all the rest of the columns in the area model, and I can tell that since the columns are all sixths, and this is one of those sixths. So I'm going to divide my 2/12 times, or divided by something over something to get 1/6. Okay. Now I know that if I divide 2 by 2, I get 1, and if I divide 12 by 2, I get 6. So 2/12 divided by 2 over 2 gives me 1/6. Okay, so we're going to do one of these problems together right now. It says, in the first area model, show 2/6. So here we're going to show 2/6. And in the second area model, show 3/9. So here we're going to show 3/9. Show how both fractions can be renamed as the same unit fraction. Okay, so here we go. So 2/6. Well, let's see. That means I need to draw sixths. The easiest way I know to do that is to draw thirds and then divide that in half. So now I have sixths. 1, 2, 3, 4, 5, 6. I need to shade in 2 of those guys, so I'm going to do that. There's my 2/6. Now this area model has to be 3/9. Well, the easiest way I can think of to do that is again to do my thirds. And this time, instead of multiplying it by 2 or drawing a line to multiply my fractional units by 2, I'm going to multiply my fractional units by 3 to get 9. right? So I have thirds and I just went to ninths. So let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are ninths. And I need to shade in 3 of those guys. So it looks like that. So there's my 3 ninths and my 2 sixths. Now, problem B says, express the equivalent fractions in a number sentence using division. Oh, by the way, in the larger, so we're going to rename these. Sorry, I forgot that part. We're going to rename these at the same unit fraction. Well, just looking at my area models, I can tell that my 2 6 here is the same as 1/3, because now this full column is 1/3 of the 3 columns. And then similarly here, my 3 ninths here is the same as 1/3 of the entire area model, because I have 3 different sections, 1, 2, 3, and 1/3 is shaded in. So now I got to express the equivalent fractions in a number sentence using division. Well, that's pretty easy. We just did that. So 2 6 divided by something over something gives me 1/3, and 3 ninths divided by something over something gives me 1/3. Well, 2 divided by 2 gives me 1, and 6 divided by 2 gives me 3. There's my division sentence. 3 divided by 3 gives me 1, and 9 divided by 3 gives me 3. There's my division sentence. Let's see, is there any more on this problem set? No, that's it. Okay, that's it for lesson 9.